Good afternoon, friends. Uh, Today we are going to discuss about the concept of OOPs. These are the pillars of that particular subject of OOPs. There are certain things like class, object, data abstractions, encapsulations, in inheritance, polymorphism, dynamic binding, and message passing. These are the pillar of the OOPs. Okay, so if we want to understand the OOP, so first we have to discuss each and everything one by one. So I'm going to start with the first one, that is class. So class is what? Class is basically the user defined data type. It simply means that it gives the template. Template means it gives the certain kind of label, the way which we want to design our class. It's kind of design. Okay, so in the class we usually contain the data member and member function. Class contain two things, and once the class, under the class we have these two things. So whatever member, either it is data member or member function, they comes under the class, they share the common properties. Okay, so class, what we can say that the object that comes under the class that share the common property. One thing that you must know regarding the class is, the class is basically the logical concept. What does it mean? It simply means that if we design the class, write the class, declare the class, it's the only thing that lies in our mind. There is no physical means that exist for the class is totally logical. Okay, so as I am telling you that class is the logical. So it's a very simple thing that when we declare the class, so there will be no occupied memory by that particular class. So in a simple way, what we can say the regarding the class is just a kind of blueprint. It's give the layout, it's give the planning, that how we are going to keep our class and what kind of structure we are going to follow. So this is about the class. And if we take the example, like here we can say in that particular diagram, suppose suppose I have designed one of the class that is known as a dog. Okay, so what is dog is there? Dog have some kind of properties, some kind of method. Okay, so now the different kind of dogs may be there. So actually the purpose behind declaring the class, that we want to create the object from that existing class. Okay, if I don't create the object with that class, then there is no use of that specific class. So here I just want to tell you that if we create the instance means if we create the particular real entity from the class, then it become the object. So there are the certain class. If I take the example like from the dog, so dog have some property like name, color, eye color, height, length. So these are the properties, and certain methods are also there, that is like get name, get color. So all these are there. Okay, so that kind of methods. Now if I create particular exact actual object from that existing class, so that existing class, from that existing class, if we give the real implementation of that particular class, that is known as a object. So in such case the value will be changed. Now the actual, suppose if I created the actual object from the class dog, so the actual object name will be like in that particular example that I have mentioned. Suppose I have created one of the object, and the object name is Tommy, and the particular Tommy, that object I have created from the class dog, that have the color green, and eye color is brown, and height is around 17. So all these are the properties that object can contain, and there are several methods that I have implemented, like get name, get eye color, get height. So all these are the methods that I have implemented. So here I have, in that particular slide we have just seen that how the from the class actual implementation of object is being done. Okay, so that is the purpose behind declaring the class, because we want to create the actual object actual thing from that existing class. Now, uh, second one is object. So already we have discussed that the purpose behind declaring class is that we want to create the object. So object is what? Object is a, if I say that actual the thing that I want to make from the class, that is object. Okay, so we can say from here that object is the real time entity. Real time means actually we deal in the object when we talk regarding the object oriented programming. Oops, so the purpose is how the object is being operated. Okay, so object is the basic runtime unit. So in the previous slide we had also discussed regarding the from the class object is created. Okay, so on the basis of that we can see that object is the instance of class. So that kind of thing is there. Now the class already, or as I told you in the previous slide, that class don't occupy the memory, but in the case of object, because there is a physical implementation of the class, is that is object. So object occupy the memory. Okay, and object has the identity, state and behavior. Already in the previous slide where from the dog class we had created the Tommy, and particular Tommy have some identity, name, state, behavior. Okay, so that kind of thing is there for the object. Now if we want to interact, uh, any object can interact without knowing the implementation detail of the others data and the code. So that is there for the object. Now we take one of the example of the object. Suppose we have taken the example of dog. So dog is a particular object. Okay, so have some characteristics, like it may be it may have some color, like color red, blue, and it have breed, like breed, bark, sleep. So these are the attributes color a dog may have. Now the particular dog have some identity, state, attributes, behavior. So these are things related with the object that is used to define the particular object. Okay, now the another concept that is used in the C++, that is known as a data abstraction. So data abstraction is simply means to hide the unnecessary detail and show the useful information. Okay, that is the core concept that lies for the data abstraction. So it simply means that providing the essential information to the end person, or anybody those who want to access the program, and to hide the unnecessary detail. It's unnecessary detail means whatever background that is going inside the program that we want to hide. So that is the core concept of data abstraction. Let's take one of the example by which we try to understand the concept of data abstraction. In a real life scenario where we usually drive the car, actually a particular person who drive the car, who knows that if he drive the accelerator, then the speed will increase, and if we apply the brake, so definitely the speed is going to down. So that kind of thing is known to particular person while driving the car. If any internal changes happen in the car, then that kind of thing is not known to the person, because driver or particular person very least concern that for the internal changes that is being done, because a particular driver or person, he is only concerned regarding the interface. Okay, so in this way we hide the unnecessary detail that is working inside the car. It simply means that how the engine is working, how the clutch is being worked. So that kind of information is not necessary for the driver is only needed to know that how where the interface is there, where the buttons are there. Okay, so that is known as a data abstraction, where we hide the unnecessary information and just show the useful information. This is the core concept of data abstractions. Now, next one is encapsulation. Encapsulation simply means if we wrap the data in a single unit. Single unit, it may be known as the class, because we deal in a object oriented programming, we usually deal in terms of the class and object. So encapsulation simply means that when we keep data and function together that bind the data in a single unit. Okay, so that particular concept is known as a encapsulation. Encapsulation simply means wrapping of data and function in a single unit, that is known as a encapsulation. So in the when we do the encapsulation, so very in the encapsulation, uh, data of the class is hidden from the outside of the world, and that is known as a data hiding. Encapsulation provides the concept of data hiding. So this is the picture by which we try to understand the concept of encapsulation. Here the class, and inside that class variable and data that comes, and it is bind together with the function, and then it provides the encapsulation. Suppose uh, in in order to take the proper explanation of that particular concept, encapsulation, we take one of the example. Suppose real life example. Suppose in a company there are various segments in which the various departments are there. Some of the department like sales department, finance departments are there. So suppose if any finance department, if the finance department want to know something, or something means, suppose they want to know the sales record from the sales department, or for the monthly basis. So directly the finance section cannot access to that particular individual department or the particular person. Okay, so in order to fetch the data from the sales section, finance department will try to access the particular sales head, and then he will be only access the information after getting the permission from the head department. So this kind of structure provide the encapsulation in the real life scenario. So this is all about the encapsulation theoretical part. So this is all for today. Thank you.